The main properties of lights like color and power are the same in Eevee as they are in Cycles, so that's not going to take any getting used to at all. But the big difference between the two render engines is how shadows interact with the scene. So in this video, we're going to look at that. I'm using this example scene from Kent because it gives us this really detailed object with all of these tiny little screws and bolts that are going to really clearly show the different shadow settings. So head over to your rendered view, make sure you're in Eevee, and let's just add a light. Hit Shift A and add a point, and bring it over and off to the side. Somewhere like that. If we go to our Lights tab in the Properties Editor, we can change the color just like we would expect. The power. We can change the specular, that's a new option, and that's just the extremely shiny point that looks reflective inside of our different materials. So this is not something that works with path tracers, but it is with rasterization engines. So if we turn this to 0, you can see that that little white little highlight, extremely shiny point, goes away, and that's called a specular. The next setting is the radius, and that's exactly the same as well. Now, when we talked about the strength to set lights in Cycles, I mentioned that it's generally a good idea if you're using multiple different kinds of lights to set the power to something more realistic and then set the exposure instead if you want things to be brighter. But there's something a little bit odd that happens in Eevee when you do that. So let's set this to 5 watts, and then let's head to our render properties and down to color management and increase our exposure. Now everything's going to be blown out because of the world brightness, but let's set this to something like 5. And then we need to head to our world properties, which we'll look at more in another video. And let's set this to 0.01. So it's pretty dim, but we can still kind of see things. Now, what's happened is that the influence of our light has really not traveled very far. We would expect it to actually spread out a little bit more than this. And that's because the distance that the light travels is kind of dependent on the power by default. But we can override that if we set the custom distance. Once we check that on, you can see that everything looks much, much better and how we would expect. If we open this up, we can set our own distance. By default, it's set to 40 meters, but we could set it to something like 5 or 10. Here, I'll just set it to 15 so that it goes across our entire scene, but not a lot further. The farther that you set this, the more that Blender is going to have to calculate, so try to keep it relatively small if you can. Now under shadow, we have a whole lot of options. First, we can just disable it completely, and that's going to make everything much faster to render, but also of course we won't have a shadow. So we want that on for most things, and we get a bunch of different options here. We have clip start, bias, and some contact shadow options, and let's go over these one by one. But first, you might notice that as we rotate around, while we're moving, we're getting this very crisp shadow, and then as soon as we let go and our view kind of settles, it jerks around a bit, and we get this more spread out and even shadow. But it's just a bunch of sharp shadows layered on top of each other. And that's something that we set in the render properties. So if we go back to our render properties, which by the way, we'll be switching back and forth between the render and the light properties pretty often, we can set the settings there by going down to shadows. And if we turn off soft shadows, then we're going to get that just one very crisp shadow. And if we turn this on, then it's going to give us those multiple shadows overlaid on top of each other. But I'd like to go into a little bit more about what it's actually doing behind the scenes. So if we turn this off, you'll see that we are getting kind of a pixelated shadow. It's not very smooth. And we can set the shadow resolution for point lights, area lights, and spotlights by using this cube size property. So if we set this to something really low, we'll get an extremely pixelated shadow. And if we set this to something high, then we'll get a very nice crisp shadow. Now what's actually doing is taking a 360-degree image, or a cube map, from this point in space. So if we look at our scene from exactly the point of view of our light, you'll notice that the shadow is exactly where this object is not. So it's essentially looking everywhere, taking a big image, and everything that it can't see is going to be a shadow. And then this resolution of the cube size is the resolution of that image that it's taking. So the higher you set this, of course, the more detailed the shadows can be, but also the slower things can get if you have, for example, a lot of lights. Because if you turn on soft shadows, then it's going to do this however many times that we have set to sample. Right now the viewport is set to 16 samples. If we set this to just 1, then it'll be exactly the same as not having soft shadows. But if we set this to 2, it's going to take 2 images. If we set this to 3, it's going to take 3 images and blend those together, and so on and so forth. So you can imagine if we set our sample count really, really high and have a ton of lights, then it's going to eat up a lot of memory very, very quickly. So you definitely want to be fairly conservative with these settings. But let's go ahead and set this back to 12. If you want to just render endlessly, I found out you can just set it to 0. I didn't know that before, so that's kind of a fun fact. But we can just set this to 12 for the time being. Now I'm also going to turn off soft shadows for now, just so that we can better see some of these light properties, because otherwise they just kind of blend together and it's hard to tell exactly what it's doing. So let's turn that off and then head back to our light properties here. And first let's look at the clip start. This is the distance at which objects will start casting shadows. So let's say we want to have our light here inside of a lampshade. Well, if we made a lampshade, let's just make a little cylinder here. And let's put it over our light and scale it down like so. And let's place it directly on top of our light. You can see we now can't see any of our scene because it's just covering it completely. And because Eevee isn't actually tracing any rays of light, can't actually tell light to go through an object, what we have to do instead is just set the clip start to be larger than the object that we want to be surrounding it. So if we have a lampshade or a light bulb or a fixture or something like that, we might want to set the clip start to be farther away than that object is. And then it's just going to ignore it when it comes to creating the shadow. So we can see that this is however many units distant from the light. We can use our ruler actually. If we use this measuring tool and measure the furthest point from the light, then it's about 0.45. So if we set this to 0.45, then we know it's going to ignore it completely and we'll get a perfect result. So that's the clip start, and I'll delete our fake lampshade here because we won't need it after that. Next is the bias. Now, the smaller that you set the bias, the more tiny details are able to cast shadows, but that comes with a price. First, we actually need a pretty big light source in order to see this a bit better. So I'm going to increase the radius a lot, like that. Now actually this looks pretty good. We might need an even larger light source to be able to see this clearly. So I'm going to switch over to an area light, which has all the same shadow properties. But I'm going to make it hit our gizmo here at a pretty extreme angle, and then just scale this up to be pretty big. Alright, now that we have a really large light and it's hitting our object at kind of an extreme angle, you'll notice that we're getting all of these really jagged edges, and it doesn't look very good. So what the bias does is allows us to kind of ignore those areas a little bit and smooth out the result. So the default is set to 1. And so those little tiny details are not going to cast any shadows. And the farther up we set this, the less they're going to cast shadows, but also the less jagged edges we get. So it's definitely a balancing act of what works for you. I find that a pretty low value works in a lot of situations, just because if we turn on soft shadows, those are going to kind of average out and we're not going to really notice those jagged edges anymore, because each sample is going to have different jagged edges, and you combine them all together, it ends up being pretty soft. But again, that entirely depends on your scene in particular. I'll turn off soft shadows again. And now we're going to look at contact shadows.